All right, today we're going to talk about inverse functions. All right, we're going to do inverse functions today and tomorrow and Wednesday. Inverses is the last before your test. So your test is going to have composites and it's going to have inverses. So a relation is a set of ordered pairs. All right, so any kind of ordered pair is a relation. A function is a special kind of relation that have distinct x values. So we talked about that at the very beginning of the year, but functions do not have repeating x values. All right, so no repeating x values for functions. Now, if a function with a set of ordered pairs x comma y what? Oh my goodness.
Hey,
there we go. So if a function that has x ordered pair x comma y, the inverse is going to be the ordered pair y comma x. So when you're talking about inverses, the x and the y switch. And we have a poster over here, our new poster, our inverse poster. It's right next to end behavior. And that is the very first thing for inverses, is that you switch the x and the y. So if you're looking at a graph or a table, or even if you're trying to solve and find inverses, you switch the x and the y around. When the inverse of a function f is itself a function, all right, so when the original function's a function and the inverse is a function, so they're both functions. All right, so when they're both functions, it is said to be 1-to-1. All right, so if the inverse and the original function, if they're both functions, our guy is 1-to-1, which means that there are no repeating x's or y values. So 1-to-1 means there's specifically only individual x's and individual y's. Nothing gets repeated. All right, so let's look down here at this chart. All right, this first guy here is 1-to-1, which means the original function is a function. It means the inverse is a function, because if these x and y switch, there is still only one distinct value in the x column. So there's one distinct value in the x column, there's one distinct value in the y column. So they are both functions. All right, they are both functions. It is 1-to-1, nothing's repeating. All right, this middle guy here, not 1-to-1. What gets repeated?
the Y's.
Yeah, the y's. So, question, is the original guy a function?
Ding, 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 ding.
Yes.
Oh, God.
Yes, the original is a function. Because do any of the x's repeat? No, so it's a function. The original guy is a function. Is the inverse a function? No. Not a function.
Okay, easy.
All right, original guy is a function because the x's do not repeat. But because the y's repeat, the inverse is not a function, and it is not 1-to-1. All right. On this one, is it a function? No, it's not a function. Is it 1-to-1?
No.
It is also not 1-to-1. All right, so the original guy, not a function. If you were to take the inverse, would the inverse be a function?
Correct.
Yes, the inverse is a function, because if these guys flip, then all of a sudden your x's aren't repeating now. So it is not 1-to-1. The original guy is not a function, but if you were to take the inverse, then the inverse would be a function. All right. Now, do you remember what test you used to, if you're looking at a graph, to determine, yes, the vertical line test. So we use the vertical line test to tell if a relation is a function. So if we want to decide if the inverse is a function, we're going to do a horizontal. So the horizontal line test is going to tell me if the inverse is a function. And if the horizontal line test passes and the vertical line test passes, then it's 1-to-1. All right, so the horizontal line test is checking for repeating y values. The vertical line test is checking for repeating x values. Does that make sense?
Yeah.
All right. So let's talk about some properties down here. The notation for inverse is a little -1 that looks like it's in the exponent, but it's not an exponent, it means inverse. All right, so the little -1 after the F, that is what inverse stands for. And you read that as F inverse of X. When you're talking about inverses, when the X and the Y switch, your domain and range will also switch because the domain, which is made up of your X's, will turn into the range, which is made up of your Y's. And your range, which is made up of your X's, will become your domain, which is made up of the X's. All right, this guy right here, the graphs of the inverse are going to reflect over the line y equals x. So over here on my graph, I have this diagonal line, y equals x, going through the origin, slope 1, 1. That is the second thing on my poster in green over there. It says it reflects over the line y equals x. So all of your inverses are going to reflect over this line. So it kind of, some people are really good visually, but if you take this paper here and you fold it along y equals x, it will match up. All right.
Yeah.
And then the very, very last property, which we're going to talk about later on today, is that f and g are inverses, then f of g of x equals x, and g of f of x equals x. And that is kind of how it relates to compositions. This guy right here is the definition of inverse functions. All right, we good so far?
Yes, ma'am.
All right, let's go to example 43. All right, my first question that I'm going to answer. What am I doing on that? Hello? Hello? I do. Yes. Bye, Peyton.
Later.
All right.
One.
All of them.
Thank you. What is it? My dog. It smells like pumpkin.
No.
Did you want one?
No, it's okay, but thank you. They're not even yours to give out.
What? Look how small yours is.
She got a whole bunch of bananas. Like I'm craving.
Wait, it's banana?
this big
It smells like
bananas.
banana.
Yeah, it's banana.
I thought it was pumpkin because it's Halloween.
Thank you, Peyton. No, it's
Yeah, thank
banana
you.
because I got a bunch of free bananas from the Iron Man.
Oh,
Big.
nice. Bye.
Hey, if you ever need to give away more, get your boy up.
All right. So I'm going to answer the question, is this function 1-to-1 first? So I'm looking at my graph. Does it pass the horizontal line test? Can you draw a horizontal line and it ever hit it more than once?
Oh, it's a vertical.
I mean vertical, sorry. Does it pass the vertical line test?
Yeah.
Yeah, it passes the vertical line test. What about the horizontal line test?
Yeah.
Yes. So is it 1-to-1?
Yep.
Yes, because it passes both the vertical and the horizontal line test. All right, so we are 1-to-1. Let's check 44. Is 44 1-to-1?
No.
No, what line test does it not pass?
Horizontal.
Horizontal. If you draw a horizontal line, it hits it twice. Does it pass the vertical?
Yeah.
Yes. Is it a function?
Yep.
Yes, it's a function. It does not pass the horizontal line test, so it is not 1-to-1. Which means the inverse will not be a function.
So if they're both not a function, it's not a function.
Correct. Wait, say it again?
If they're both not a function, is it still 1-to-1?
No, because they would both have something repeating,
Then it's just not a function.
and it's just not a function. Yeah.
What does that look like?
Now watch this stuff.
A circle.
Ooh.
A circle. The inverse would be another circle, but neither one would be a function.
Okay.
Alrighty. So we've answered the 1-to-1 question. Now let's look at the graph. Some people are good visually, and sketching the diagonal line might be helpful. I don't know why it's so blurry, but. All right, so the diagonal line, which is going to go through the origin, and be like a 1-1 slope. All right, my line is going to reflect over this line. And if you can visually see it and then just draw it, by all means, go ahead and draw it. But for those of you that are not good at visually seeing this, what I would recommend to do is to draw a table. And we are going to find some points on my original graph F and put them on my table. And we're going to kind of just spread my points out here. So like, I'm going to get the vertex point. That's probably an important point. Where would this be at?
-3, -2.
Yep, -3, -2. And then I see we're crossing right here at 1, 0. And just so you know, you do not have to always pick a perfect point. You could pick at a decimal and guesstimate. So I could pick 7 and then like 1.2. Or yeah, 1.25. That works. 1.25.
That's cool.
You also could pick 6-1 if you wanted to keep it nice. But I want to do an example with a decimal just to show you that you can use decimals if you want. All right, so this is my original graph. Now, if I want to come up with a table for the inverse graph, what am I going to do with these points? Do what? Flip them. Yes, flip them. So -2, -3 would be a point on the inverse. 0, 1 would be a point on the inverse. And then 1.257 would be a point on the inverse. So I'm going to take my new points here that are on the inverse, and I'm going to plot them on my graph. So -2, -3 is going to be right here. 0, 1 is going to be right there. And 1.257, 4, 5, 6. Oh, that goes off. That's okay, though. I'll be up here. Your graph is going to be the same shape. So since my graph has an endpoint right here, it's going to have an endpoint, and then it's going to be an arrow with a little loopy, but it just is going to be going upward.
Yeah. Right?
And you can kind of see that my green line and my original line there, they do reflect over each other if you would fold them along that diagonal line. All right, but if you can't see it, it's okay. You just got to find some points and plot them. All right, now on your homework, you have some domain and range questions. So, the domain of F. All right, so the original guy, how far does the original guy go to the left?
The original guy go to the left to -3.
-3, and it goes to the right.
Infinity.
Now, how far does the inverse go to the left? -2, and how far to the right?
Infinity.
Infinity. But if you notice, the domain of the F graph, -3 to infinity, the domain of the F inverse is actually going to be the same thing as the range of F. All right, the range of the original, because they'll flip-flop. But you can find it either way, so you can find it whichever way you want. So like if I were to do domain and range of this one. All right, what's the domain of the original? How far left is it going? Forever. How far right is it going?
Forever.
All right, so I don't have the inverse graph, but I can actually still come up with the domain of the inverse because it's going to be the same thing as the range of this guy. So what is the range of this one? How far down is it going?
2.
-2. And how far up is it going?
Infinity.
Infinity. So that should be the domain of the inverse.
So it's just the range.
It's just the range of the original because they'll flip-flop. All right, but let's figure out what the graph actually looks like. So I'm going to come up with some point values. All right, so 0, -2, 2, 2, and I got 2, -2. That's probably good. And then for the inverse, I'm going to flip it. So -2, 0, 2, 2, and -2, 2. Wait, hold on. There you go. I have my negatives in the wrong spot. All right, so I'm going to plot my points here. So -2, 0, 2, 2, and 2, -2. And it's going to be a similar shape. So it's going to be like that U shape. But remember, the domain should match up with the range of the original, and the inverse is probably not a function because the function is not 1-to-1. And it didn't pass the horizontal line test, which all of those things track with the picture that I drew.
Agreed. Wait, so if it's not 1-to-1, then you can't do the...
You can draw it, but see this U here, it's not a function.
Do we have to draw it? Like, is it, or are you just like showing us?
The directions on this one said to draw it, so if it tells you to, then yes.
Oh, wait, never mind.
That's just like overthinking it.
Okay, so let's talk about your homework for a second, because I'm going to pause and I'm going to let you work on it for like 10 minutes, and then we're going to finish the notes. Ooh, maybe like 5 minutes. I don't know if we have 10 minutes. All right, on these first couple, you are going to sketch the graph of the inverse. So if you need to make a table, make a table. If you can visually see it, that's also fine. And you're going to tell me the domain of the original and the domain of the inverse.
So just find the range of the first one.
Yep, and so the domain of the inverse, you could do two ways. You could do the range of the original, or you can actually graph it and then come up with the domain. On these bottom four, don't overcomplicate these bottom four. You are going to use a graphing calculator to get the shape of the graph, and I want you to sketch it on here. It obviously does not need to be accurate. There are no coordinate points or no grid lines for a reason, and all I want you to do from the picture is to tell me if it's 1-to-1. Tell me if the inverse would be a function. So you do not need to graph the inverse. You just have to say that it is 1-to-1 and or not 1-to-1. All right, so you're sketching the original, and then from the original, you're going to tell me if it's 1-to-1 and if the inverse would be a function.
Can you go back to the notes page?
Yes.
I want to see how you are. Tweaker. I can't. Yeah, okay. It was,
Oh, it was blank again. I don't know why it keeps doing that.
Brackets and stuff.
Yeah, because it's a coordinate.
Sure. All right.
Okay, I'm going to give you like 5-ish minutes. I want to make sure I can do notes, but get a little head start here on the homework. And if you don't have a calculator at home, you might want to start with those bottom four. Do you need me to?
X squared. So that just gets rid of that.
And let me know if you get stuck.
How'd you do number 7?
Well, you gotta sketch. You gotta sketch stuff. You need a calculator.
You do?
You put it on the calculator.
Oh, that's smart.
No, that's what you're. You know.
No. It's just unplug it for
No. It's wrong.
Wait.
It's still me. So it's 0 to infinity.
Oh, yeah, 0 numbers.
the drawing for this one.
Alright, 10 points if they got the inside number, 10 points if they got the answer. Does that make sense? Yep. And then if they just got the answer, then that's fine.
Rate relief. Test
So close.
That's right.
Yeah.
Wait, so none of them are not a function?
Like, they all pass it?
Yeah, on the Punnett squares. Or like some of them are not one-to-one, but all of them are.
Oh, yeah, so if it's not 1-to-1, then the inverse wouldn't be a function. But the originals are all functions, because if it's not functions, you couldn't graph them on the calculator.
I like how she knew what I was talking about from Punnett squares.
I did. That's not what they are, but I knew what you were talking about.
Close enough.
Mike, you didn't
Yeah. I don't need them. And then we don't do the back until
Yeah, I'm about to start.
Okay.
Yeah.
How many did you do?
Yeah, those. I thought I lost them. And so I was like, oh, I guess I have another.
All right. Let's talk about the next couple. All right, so the next couple are more algebra, and we are going to use the definition to prove that these guys are inverses. So I'm telling you that they're inverses. So your work is showing me the answer. So if you just write, yes, they're inverses, that's not showing me the work. So I'm going to be very specific what I need, so when you do it on the test, you know what I'm talking about. First thing is you have to show me that f of g of x is going to equal x. And you have to go the other way, and you have to go g of f of x and show me that that equals x. So you have to go both ways.
So this is just like lazy work.
It should be easy because everything should end up canceling except for x, but you have to do it in steps. So this is where the composites come in. So for this first one, we're going to take this fraction here, the x minus 1, and we're going to plug it in to f. So I've got 7, and then I have x minus 1 over 7 plus 1. Now you have to do it in steps. What cancels first?
This
The 7s, and then you write
x1
x minus 1 plus 1,
which cancel to give you x.
which cancel, and then give you x. So you have to write the steps. Don't just cross everything out. I need to see that you know which one cancels first. And then we're going to go the other way. And so now we're going to put 7x plus 1. We're going to put that into g. So 7x plus 1 minus 1 over 7. So what cancels first?
7 sevens.
The 1s. You have to cancel the 1s first.
I cancel them in this step.
You can't just.
You can't cancel them in the same step. Different steps. One at a time. So cancel the 1s, rewrite it, then cancel the 7s.
What happens if I cancel the 7 plus 1?
You can't. Because they're not really 1s. They're 1s divided by 7. So if you cancel these 7s, then you're ignoring the fact that these 1s are being divided by 7.
I would never do that.
I think they're just being picky.
Okay. So let's try it again. So we're going to first verify that f of g of x equals x and g of f of x equals x. All right, so for the first one, I'm going to take this cube root and I'm going to plug it in to the x in the f equation. All right, so I have 1 minus cube root of 1 minus x and then cubed.
Cancel the cubes.
Cubes cancel.
1 minus 1 minus x.
So you're subtracting everything in the cube root.
And then you distribute.
Yes. So make sure you keep it in parentheses. It is 1 minus and then in parentheses 1 minus x because this negative has to get distributed. which is 1 minus 1 plus x, which and then the 1's cancel, and then you're just left with x.
Oh, daddy. I don't like this one. Almost bad.
All right, so now you're going to take f, and you're going to plug it in to g. So I have the cube root on the outside, 1 minus and then in parentheses 1 minus x cubed, because we are subtracting all of f.
So tell me you get rid of those cubes first.
No, distribute the negative.
Distribute the negative. So cube root 1 minus 1 plus x cubed. What's going to cancel?
Cube roots.
Before that, the ones, and then the cube roots. So you will cancel things in a backwards order. So on this first way, I did the ones, or no, sorry, I did the cube roots, then the ones, right? So I did cube roots first, then the ones. And this one, I'm going to go ones, then cube roots.
Yeah.
All right, and then in the first guy I did the sevens, then the ones. So in the other way, I'm going to go ones, then sevens. So you do them in the backwards order.
And you have to write the F of
Yep. So when you're taking the test, there's going to be one question on the test that's like this. That's exactly what I'm looking for. All righty. Now for the fraction. The fraction's the hard one for today. So everything else for today is pretty good except for the fraction problems. That's kind of a lot because it's just knowing your fractions. All right, so we are going to start off with f, and then I'm going to put g of x in the f guy, and that should equal x. All right, so I have 2x plus 3 over x minus 1 plus 3 still on the outside, and then 2x plus 3 over x minus 1, and then minus 2. All right, so this big guy right here is replacing these two x's with that fraction. Does that make sense? It's not hard, just write neat. Now, you cannot cancel these guys.
Yeah.
Cannot. Because this one has a plus 3 and that one has a minus 2. So you can't cancel something if it has other things being added to it that are not the exact same thing. You can't break up stuff that has stuff being added and subtracted. So what we have to do now is we have to get a common denominator. So what am I going to multiply on the top and the bottom of this 3? Oh, I'm sorry, just the common denominator with the
Oh, okay. So X minus.
x minus 1. And then what are you going to multiply on the top and the bottom with the 2?
X minus.
X minus 1. All right, just like we did when we did our fractions at the beginning of the year, I'm going to rewrite this. So my denominator is now x minus 1, and everything on top, I'm going to just write on top. 2x plus 3.
Plus 3x minus 3.
3x minus 3. All right, on bottom, same thing. X minus 1.
2x.
Everything on top is going to get written on top. So that's the green highlighter. And then I've got 2x plus 3 minus
2x
plus 2. All right, that's the hardest part right here. Once you get to that stuff starts canceling. And you can cancel multiple stuff in this step. All right, so kind of take a gander at this guy. And let's look and see at what stuff is going to end up canceling.
Let's look.
Let's look. What do you see cancels?
The 2x.
The 2x's. All right, 2x here, 2x here.
And you can combine like terms.
Something else cancels. The 3's. Plus 3 here, minus 3 here.
Oh, I was just looking at the bottom.
And what's special about the bottoms?
They're both X.
They're both x minus 1, so those will also, the denominators will cancel. Because they're the same.
Alright.
All right, so on top, what are we left with?
3x,
Plus.
2x,
And on bottom, what are we left with?
2 plus 3.
And so then when you combine like terms, you get
3x plus 2x over 5. Oh, 5x over 5. And then the 5's.
and then the 5's cancel. Oops. You don't have to write this step if you don't want to. You can go straight to 5x over 5 and then cancel and equals x. Okay. We gotta go the other way now. That's why I said this is the hard ones. Okay, so now we are gonna go g
Very valuable information we need to know.
of f of x.
I want to be a welder.
All right, I don't make you do a lot of them. All right, so in place of the x's right here, we're gonna put this fraction. So I've got 2 and then x plus 3 over x minus 2 and then plus 3 over x plus 3 over x minus 2 minus 1. Okay, steps are the same. Common denominator is going to be x minus 2. And so we're going to write that as one giant fraction. Okay, what is going to be the denominator?
X minus 2.
X minus 2. And then all of that stuff goes on top. So I'm going to distribute the 2,
2x plus 6
distribute the 3.
plus 3x minus
All right, so that's all that stuff. And then we're going to do the same thing on the bottom. What's the denominator on the bottom fraction? X minus 2. And then we're going to distribute all this stuff on top.
x plus 3
Distribute the negative 1.
minus x plus 2.
All right, so all of that's from that.
It's just the same.
Yes, it is. It's going to be the same.
We just have to
You have to show your work. So what's going to cancel
the 6's.
the 6's,
And then the x minus 2's.
the x minus 2's, and the x's? And so then what are you left with on top?
2x plus 3x.
Which is?
Wow, 5x.
And what are you left with on bottom?
3 plus 2.
5, which is going to cancel and give you
That's
X.
so good.
the same thing. Yes. So this fraction part right here, that's the hardest part. Once you get to this step, everything should cancel and you should be left. It follows kind of that same pattern for the fraction inverses. Okay. So I know it seems like a lot, but it's really just a lot of common denominators, which is something that you need to know how to do. Okay, I'm done. Yes. On your homework, 10 and 12 are your 2 fraction ones. The other ones are not that bad. And then on 13 and 14, those are multiple choice questions. All right, so don't think it's like multiple parts. It's a multiple choice question. Is that okay?
Yes, ma'am.
Mm-hmm.